Good morning, everybody. Today is 29th of December, which means two things. First, this year is finally coming to an end. And secondly, Scala 3 is soon to be released. I haven't done Scala during the last 3 years, but luckily today we have my good friend and staff engineer at Disney Streaming Services, Anton, who will tell us a little bit about what Scala 3 is, how it is different from Scala 2, what are the distinctive features, and all this kind of stuff. Anton, hello.
Hello.
As I said, you are a staff engineer at Disney Streaming Services, and you're talking about Scala today. So could you tell a little bit about how you use Scala at your job? Do you use it? What is the size of the deployment? And all this kind of interesting stuff.
Yeah, so unlike you, I've been doing exactly only Scala for the last 3 years. So that's all I've been doing. And I work for Disney Streaming Services, and I work in particular in the user services team. And our main product is a small streaming service you may have heard of, Disney Plus. So it hit 80 million subscribers, and a large part of the backend code for a lot of the services, specifically in the user services, is pure Scala. So everything that has to do with authorization, accounts, profiles, devices, or everything has to do with basically user information is all written in Scala, along with a lot of the supporting infrastructure like Lambdas and backend jobs and all of that sort of stuff, along with many other teams. So there's a lot of Scala in there.
So let me guess, everything that is working fine is written in Scala, right?
Pretty much, yeah. I'm not going to go as far as to say as the only things that are working fine are written in Scala, but a lot of the other stuff is written in Java, Kotlin, and some of the languages. But the Scala deployment is huge and is getting bigger every day.
All right. And do you have any immediate plans about like Scala 3 migration, or for now you're just observing?
So it's a very hot topic for, like, in the principal engineer group. There's discussions on how to make the transition smoother and make the transition safe. But at the moment, given that a lot of the code bases are kind of spread across 2.11, 2.12, and 2.13, the direct jump to Scala 3 is not really in our plans, and specifically because the Scala 3 is a new compiler, that we will need to make sure that everything works, and a lot of the dependencies are published and working. But to be honest, we're not that fussed about it because the final version hasn't come out yet, and next year we're going to be transitioning all of our code bases to the latest 2.13, and the jump from 2.13 to Scala 3 is a lot less scary than it would have been from, say, 2.11 to Scala 3, like what Spark would have had to do if they didn't jump to 2.12 recently.
Right. And you said that the final version hasn't come out yet. So what version of Scala 3 we will be discussing today?
So we will be discussing Scala 3 Milestone 3. That's the latest one that came out. And it only recently, Scala 3 versioning changed from, first of all, the name changed from .t, and the version changed from like 0.27, 0.28 to actual 3, when the decision was made that .t compiler will become the Scala 3 compiler.
All right. So, and I guess this is a good time to talk about, let's say, I want to start writing Scala 3. What do I do? Like with Scala 2, I have a good idea about the tooling. Like I know about SBT, metals, and all this kind of stuff. So is it any different with Scala 3? Like how do I use it?
Not really. So if you already have SBT installed, you have everything to start writing Scala 3 anyways. There's only one small difference, and I'm going to demonstrate it in a second, where the artifacts for Scala 3, like the Scala 3 library, which is actually a library from 2.13, so it's using the same standard library at the current stage. They're published with a Scala 3 prefix in the name of the artifact, and SBT in the current version doesn't resolve that correctly, but that is fixed using a Dotty plugin. So it basically, to start writing it, you just need basically 2 lines of code in your SBT configuration. So it's pretty simple. I can demonstrate if you want to jump straight into this.
Sounds manageable. So no, I think we should be fine here. So maybe we could start actually and do some coding. And I know that the first feature that you're really excited about is like enums, and these are not the type of enums that we have in Java. So let's jump to the code, and it would be cool if you could demonstrate what are Scala's enums, what are they about, how they're different, and what's so cool about them.
Okay, well, the first thing that we actually need to do is to start the project. So we're going to do our build SBT. We're going to set the version to 3.0.0 Metals is already trying to import stuff. So that's one file that we created, build SBT with 1 line, and we need another one, project/plugins SBT, and we just need to add the plugin for Dotty, which I think that's what the coordinates are. So SBT Dotty, and the version is 0.5.1. So
that's a good memory.
Oh yeah, no, I've done that multiple times. So that's the only reason I remember. The correct ordering of like CH, EPFL, and LAMP, that's always difficult to get. So whilst it's importing, we can actually run SBT in the terminal ourselves. And we can create as an actual source file. So let's do
the terminal here.
Yep, src. Right. Okay. So src main Scala main dot. You wanted enums, so let's talk about enums. So enums.scala, that should be done. And in the terminal, let's just make sure that. Yep, that seems to be working. In the terminal, that's also working. Beautiful. Okay, so what I'm going to do first is I'm going to put this on a loop to compile everything. I'm going to create another terminal, which you should be seeing in. I'm going to create another terminal. What I'm going to use Bloop. So it's all of that tooling is from Scala 2 days. So there's nothing really special about this. All I'm going to use Bloop for is just to run the particular class where we're going to be demonstrating. Okay. So enums. Okay.
Just to make sure, so right now it says that it can find a load main class enums. That's expected.
Yep, that is expected. Cool. The reason for that is that we only have one source file, and it doesn't have a main method.
Right.
So that's actually one of the kind of smaller features of Scala 3. So just to make it quick, we can define a main method. We'll call it enum, and we're just going to test. Yep. So you can see that hello is running, all good.
So but let's maybe stop here a little bit. And so I see that main kind of makes this enums function like an entry point. But the question is it some sort of annotation that was set by Scala 3, or it is some other kind of magical stuff that somehow transforms the code? How does it work?
Yep, so this annotation was added in Scala 3, and I think it was added after the success of Ammonite scripting environment for Scala, which used pretty much the same annotation main to turn your functions inside of one script into actual runnables. So in the bytecode, it actually creates a enums bytecode class, which actually has an entry point that the Java will recognize. So it actually creates a main method for you and everything that you would need. So it's just a much shorter way of writing the same thing that you would do, like enums and main, args, array, of string, and etc. So, and one of the nice features is that it has some very rudimentary kind of command line argument parsing. So you can do hello string, and then can do that. And then it's going to probably complain that, yeah, more arguments expected. So if we rerun it, it's going to do hello Artem. Oh, well, sorry. That was silly of me. Something like that. Yeah.
All right.
So basically, it's just to simplify the fact that every single time you write a main application, you either have to inherit from this special app trait, which does some magic, which actually will go away in Scala 3.1. So before that, you can do something like this. And I think in the current version, it will still sort of work, and it will define kind of two main classes, but this way of writing it will go away. So this is just a simple way of writing things that become executable straight away.
Right. And I'm guessing this annotation is just imported by default, like it's a part of the prelude.
It's in predev.
Yeah, got it. Actually, can we get to the bytecode just for a sec?
Yep.
So this command line parsing, how does it look like? What do we have?
So this is, yeah, you can see that it's actually coming from the Scala util command line parser. And I actually haven't looked much into it. I think it's pretty trivial, and it was probably designed to make some headway towards replacing some parts of the Ammonite and putting them directly into Scala because of the success of Ammonite. But I think it's just very simple. So if I remember correctly, it doesn't actually handle options.
I see.
So, which Ammonite also doesn't. So yeah, there we go. No implicit argument. But I think the design of it is based on implicits. So you could define your own, implicit converter from a string, which is an argument, to an option of string. So you can sort of get away with not using any command line parsing library because some of the very basic parts are already in the main.
Yeah, this is amazing.
Library.
I mean, this can simplify a lot of, scripting that you do for your hobby projects, or even, small stuff at work. Just less code to write, less opportunities to make bugs. So this is really good. All right. Right now we know how to run stuff. So let's get back to enums.
Yeah. So in its simplest form, enum can be defined like this. So you see there's a new keyword and just a new way of declaring certain things. So you can define certain things that you would probably get with libraries like enumeratum, or you would get with Java lang enumeration. The problem is that Java lang enumeration kind of erases to integer, and all of the enums then become exactly the same. So on the type level, those two enums are just perfectly fine, and they are distinguishable, and the compiler knows the difference between them. So that's just a simple way of defining enums, but in the Scala 2, the way you would do that, you would do something crazy. Well, not crazy, but it's a lot longer. So you would do object red, you would do case object. Yeah, so you need to extend color, you need green. And that would get you roughly the same thing. So enums have their overridden toString method, they have equality correctly defined, hash code, and all of that stuff. So you would get the same effect, but it's just in Scala 3 it's a bit shorter. Where it goes a bit further than that is that it's not just enums for static values. You can define the same things that you would use kind of seal trait hierarchies in Scala 2. You can define them as enums. So you can say case red and intensity will be double, case green, and you can say that emerald is boolean, which is equals to true, and case blue is C like, also boolean. I mean, I shouldn't have improvised this. So you can define those things, yeah, and you get like pattern matching on those straight away. So all of those cases are not imported directly outside of the enum. So the Scala compiler generates a companion object for you. So you can create your own values. So color.red, intensity, yeah. something like that. So exactly how you would use it in Scala 2 is just it's a bit simpler because it creates a sealed hierarchy that you cannot extend. It creates a companion object. It creates all of the other things that the case classes would give you in Scala 2, just in a much shorter way.
So just to make sure that I got this right, is it just like a syntax sugar, or there is something else to enums?
So I think there's two aspects in here. For the most part, it's syntax sugar that generates pretty much the same thing that you would have written manually. So when you would define a sealed trait, kind of like algebraic data type in Scala 2, you would use sealed trait, you would use case classes, you would make those case classes final, you would create a companion object, you would create kind of custom values, you would do all of that. So it generates this all for you. And where it kind of goes beyond the syntactic sugar is how flexible it is. So it's not just for the simple cases, it can go beyond that. So you can create, ADTs with type parameters, GADTs or whatever. And
maybe we could try that actually.
Yeah, let's see how this goes. So let's define something like a tree, which weirdly enough is like everything that Martin Odersky is using in his presentations. He loves trees. I think that's because it's big. Yeah,
I mean, as a compiler writer, you have to love trees.
Yeah. So all of the examples are usually trees in one way or another. So we can create a tree which has two alternatives. So the value in a leaf node, and we can also say that it's some sort of branching node which has like subtrees, vector of tree of T. And that kind of gets us somewhere because you can now create trees. So you can say leaf of 25. So obviously it complains that it's supposed to be an integer.
Right.
So that'll be that.
And I guess you can just omit that at all, right? I mean, the type annotation can be properly omitted.
Yeah. So you can just do that.
Right.
And then inside of the enum definition, you can go further and define certain things that transform your enum. So because the type parameters defined on the enum itself are available in all of the definitions inside of this kind of enum block. So you can have a method called map, for example, which converts a tree of T into a tree of X. So you can just annotate it like this, and you would do some sort of recursion on this if you wanted to. So tree of T, which produces X, and then you get exhaustive pattern matching like you would with the regular case classes and sealed traits. So you can do leaf F of value, and then for the subtrees, you can just do node subs map go, and go. And you also have this available, which is the current instance that you're working on. So in this case, we can just create we can actually map over our tree, and we can say, well, something that we shouldn't be doing, but calling toString on it. Yep. So we got leaf 25. Well, I probably should have added something like this so that it doesn't look like it wasn't converted at all. So you can define those things, and everything else is available. And you can see that we only need one type parameter. So that syntactic sugar goes a long way in defining certain things for your enum that you would have otherwise put into type classes or companion objects. It's kind of all available in there, and this refers to the current node, so you don't need to do a lot of that inheritance stuff.
All right. Yeah, I mean, this is definitely a quality of life improvement.
Oh, yeah.
I mean, I know that, let's say, if you sort of at the advanced side of things and you have been using enumeratum and all this, compiler plugins, probably it is not kind of revolutionary, like this sort of change, but hopefully it will just cut the boilerplate further for a lot of other people who either cannot or do not want to use compiler plugins.
Exactly. And one of the main goals of the Scala 3 was removal of surprises from the compiler, adding new features such as this one. But mostly those features are added as the compiler, like the Scala 2 compiler, has been used for so many years. A lot of the features that are delivered by the libraries turned out to be useful enough to roll them into the compiler itself.
Yeah.
So a lot of the things that the Scala 3 promises are improvements and sort of canonical implementations of things that kind of proved to work well in the industry.
Yeah. All right, so what is the next feature that got you excited?
Opaque types, maybe?
Opaque types.
Is that the one that we want? Is that the one that we want to talk about?
I want to talk about it. Do you want to talk about it?
I do want to talk about it.
All right, so let's talk about it.
Yeah, let's create another file, which I'm gonna opaques. I'm gonna remove all of this. I'm also gonna remove and rename this to opaques and change Bloop to run opaques. Right. Okay. So in the Scala 2, one of the most kind of used tricks was using value classes. So value classes are the sort of the holy grail of working on the JVM, where you want to avoid boxing as much as possible, and you also want to get some sort of type safety guarantees. When you have a lot of types which are exactly the same, so they're all technically integers, but you don't want the user of your code to be mixing them up.
Yeah, so maybe just before we dive into opaque types, we could talk a little bit more about value types, or also those are called new types. So why would you use one? And what are the cases where you would use value types or new types or this kind of pattern in your code?
Yeah, well, doing type-safe programming, when you're doing type-safe programming...
What's wrong with integers, let's say?
Oh, integers are fantastic.
Integers
it's just all strings, integers are exactly the same. Yeah,
it's like bread and butter, you know?
What else do you need, right? So in a while, like in the beginning, that's all that was needed. And then you get to mix up certain integers. You can think of like examples where, and I have a couple examples that I might show later on, but you can think of examples where the representation of, say, identifier as a string or password as a string, whilst at runtime you would love them to stay the same because that's the most efficient representation instead of adding yet another class on top of that. That's at runtime the most efficient representation, but at compile time, you want to force the compiler to tell you that you're using identifier as a password or vice versa. So a way to encode this information of types that are at runtime should be exactly the same, but at compile time you can verify that your program is not mixing the different meanings of those strings. That is a very important thing, and Haskell has it as new types, and in Scala there is like value classes, AnyVal classes, or there's some libraries called, well, Scala newtype, for example, that use a bit of macro magic and type tagging just to make sure that you can designate that this string is a identifier and this string is a password, and the compiler should scream at you when you're trying to, hash the identifier and print out a password.
Yeah. I guess another example is when you have something like different types of IDs, like user ID, employee ID, card ID, and you don't really want to mix them up. So how would you do this in Scala 2? How would you define a value class?
Yeah, so in Scala 2, the syntax is innocuous. So you can define a case class. It should have a single parameter, and that parameter can be of, well, actually I don't remember of any type or what, but term ID. Usually it's used for the types that we consider primitive, because there's no such thing as primitive types in Scala. In Java you have integers and you have int, and you want to use int as much as possible because it avoids boxing. But in Scala, there is no such thing as a primitive type. You have int, and the compiler decides when it wants to box the int into an integer on the JVM, or when it can use the primitive type, which is a lot more efficient. So because of that, it from an ergonomics point of view, it's a lot nicer to work with those types, because you don't have to worry about manually boxing and unboxing. But then you take a leap of faith that the compiler is going to make the right decision and not unnecessarily box your integers, for example. So it's a trade-off between having access to low-level primitives on the Java side and having a nicer kind of UX on the Scala side.
Yeah, and just from the experience, like the compiler doesn't always make the right decision. And
No,
yeah,
it's difficult.
And I know there's a lot of sort of issues with this. So could you just continue the definition?
Yeah. So the definition is like this: single parameter, and it has to inherit from the AnyVal, which AnyVal is sits in the Scala hierarchy, which I think basically a lot of the types extended. So any is at the very top, AnyVal is all of the value classes, and then there's AnyRef, which is all of the sort of normal classes, which are references.
Yeah, but
so they cannot
but the caveat here is that value is not exactly the value all the time. I guess that's one of the problems. So could you maybe elaborate a little bit? What's wrong with the AnyVals? And
so yeah, let's experiment with a little bit. Well, the first thing is that the AnyVal actually doesn't prevent you from overriding certain things like equals or hash code, and that poses problems because basically the languages on the JVM, specifically Scala with its interop with Java, they cater to two different groups. The groups that use inheritance and method overrides, and they really want to be able to delegate certain decisions to the standard way that Java code bases are implemented, like using equals or using hash code for hashing. So for that, this will necessarily be boxed because you need to access the actual implementation of equals and hash code on the particular instance of this term ID, for example.
That's right,
class. Yeah. So in some cases, it looks great. So if we basically have a function, well, I shouldn't have called it function, check, right?
Okay.
ID is term ID, and it's going to be basically checking that underlying is more than 0. So if we take a look at the bytecode, hopefully my script works. It doesn't. It does look like it's. Does it work? Oh yeah, it does. Okay, so
let me switch to the bytecode.
You should be. Yeah, it looks like you're following in there. So we're looking at the main one, and the main one is it invoking anything? No, so it's delegating to the package object.
So the name of the function is check, so let's search for check. I actually don't see anything with the name check.
Huh.
Maybe you should use it. Maybe it was just removed.
Maybe it was, that's weird. Okay, so let's try this. Term ID 25. Yeah, so if we take a look at the apply method, it all looks great so far. So the apply actually just returns an integer. So it loads its first argument. So this is the apply method on the case class term ID that was generated. So it takes its first argument, pops it on the stack, and then does an I return, which is a prim. Well, I mean, you know bytecode better than I do. That's a primitive return, right, of an integer. Yeah, so it returns that, as opposed to, I guess, a return, which is a reference return.
That's right.
Yeah, and it's the same with unapply. So when you're pattern matching on that instance, it's just going to pattern match integers, which is great.
Yeah.
Now, if we could find the check itself. Oh, there we go. So we've got check. Just using invoke special. So the first one is invoke virtual on the term ID. That's fine. Does do I-return as well.
So
Maybe
what are you looking at? What are you looking at?
So this is the main method of the Opaques class that we just wrote. I think you're in the right place. You should be in the right.
Actually, it doesn't seem so.
Let me just do something silly.
Yeah,
so I'm just
work.
going to copy and
This
paste
should
this.
work.
Yeah. So this is the bytecode. Magic, right? That's the bytecode for this method. I wish there was an extension that showed you that. That would be really cool. So how do you read this? Tell me.
So basically what we have here is we call apply, we have integer as a result, then we invoke the check function with invoke special, and then return another integer. And again, the input is integer. So it seems that everything that is happening here is happening with primitive types. So no boxing, no anything.
Fantastic. Well, so what if we have another function which takes a list of those things, and we want to make sure that for all of them, for all of them, the check is satisfied.
Okay.
So as this regenerates, I will copy paste it again, because apparently that's what we're doing. So I am going to copy the entire thing now, and we can see if we can spot the allocation.
All right.
We should.
Let's play the game.
That's the promise of that's the promise of the blog post. Well, actually, yeah, you can see it straight away.
Yeah,
so,
we actually create a new instance here of the term ID class.
And exactly. So it gets created, and things get worse because it gets boxed and unboxed if you map over it. And as far as I remember from the multiple snarky blog posts about how AnyVal is not really the solution to this problem, is really just to support the ability to do things like equals hashcode and is instance of or as instance of. So it's not really a solution that behaves the way you expect. You would want this to be erased to a list of integers at the very least. And the same happens with, I think, the generic parameters. So if term ID becomes part of the generic parameter, on which, so in the type safe code, you would not be invoking things like equals or is instance of or hash code or toString on a generic parameter, because in Scala, the preferred solution is to use type classes, which on a type level give you access to certain functionalities. Like instead of toString, you get a show class. Instead of hash code, you get a hash class, and etc.
Yeah.
But because everything sort of inherits from any, and any has a lot of methods from the Java lang object because they're almost equivalent, then just to be able to support this, the Scala compiler will box it if it's used as part of a generic function application, which this is. Like the list.apply is a generic function, so therefore necessarily this has to be boxed along with the primitive to support the dispatch of those methods.
That's right.
Does that make sense?
Yes, it does. So we can see that AnyVal doesn't really kind of solve the newtype use case for us.
Yep.
So let's actually get to opaque types and see how those are different.
Yeah, so let's comment this out. Well, actually delete it. What we're going to be using is opaque types, and opaque types are a solution to this exact problem, that the behavior of boxing and unboxing is unpredictable. So the Scala improvement process document that is talking about the opaque types defines a new soft keyword for those. So let's say we have term index object, right? And inside of it, we want to differentiate between, say, term IDs and document IDs and occurrences. So we are modeling something like this term occurs 20 times in this document, for example.
Okay.
So we're trying to build this sort of data structure. And in that data structure, we already have things like term ID, which is really an integer, because for efficiency, we want to pack them as integers, or like in binary or in JSON. We also have things like document ID, which is an integer. And let's just remove all of that. We have document ID, but we also have occurrences, which is not an identifier, but it's also an integer. So we have those three types, and we want to model a data structure, which is basically data is a map of term ID and a vector of document ID and occurrences. So yeah, like that.
Okay.
So basically a dictionary, to be honest, of term IDs and documents and how many times they occur. So the way to use opaque types in this is pretty simple. You just add the keyword opaque to the type alias.
All right, so that's much better than the KX class that extends AnyVal.
Yeah, the word opaque itself is probably not more clear than like AnyVal, but
for sure.
In terms of the number of characters to type and just the ergonomics of it, it's much better. So
yeah, but to be honest, like opaque is not less clear than newtype and Haskell. So it's unless you know what this is, like the name doesn't tell you much.
Yeah, and the good news about opaque types is that, and the sort of the main feature is that they promise the same guarantees as the Holy Grail, or like no allocations. And in the runtime, this will become just a map of integers, integer to a vector of integer and integer, or we can pack it even tighter. But the thing is, within the scope where the opaque types are defined, say this term index, they will be just type aliases. There's nothing different about them. So we can theoretically do something like this, which is term ID equals 5. D is document ID equals 10. And we can do just I plus D.
Oh, wow.
The reason we can do that is because, in this scope for efficiency purposes, and actually for the ability to express certain things, they are exactly like type aliases, which means that you can define certain methods that work with those type aliases and treat them as integers if you wanted to, for simplicity. And one of the ways to do that is, because at the moment you can see we're not defining a class. So with the AnyVal, we had a class and we called it term ID, and we had a body of that class where we could have defined methods, right? So how do we do it here? Well, the thing is, outside of the scope of the definition of the opaque type, it's a type which has basically almost nothing at all. So you can't create instances of it. So if we try to do this, even if we import that, the entire thing, the compiler should complain. Yep, there we go. So the compiler says that found integer required term ID.
Let me
so you can't
focus on
create.
This. Yeah.
You can also open the terminal. I think Dotty has greatly improved the compilation errors. Like that's one of the main things. They are now more colorful. So you know, which is great.
Sure, more color into life.
So yeah. Exactly. Otherwise, it's really boring. Like terminal support now is 65,000 colors or whatever. So why not have more color in your errors? So outside of the definition, they are opaque. There is nothing that is known about them. They contain no values, and you can't construct those values unless you permit someone to do it. So, and the way to do that is each opaque type alias actually defines a type companion. So you can say occurrences object, and you can put methods in here. So you can say a safe construction method, for example, option of occurrences. Yeah, so we can just do option of I and filter that it's supposed to be more than 25, for example. Which means that after that, we can create outside of the scope where the type alias is defined, we can create safer instances. And the promise, given that it's a new feature, it's difficult to say that it's a guarantee, but the promise is that in all of those situations, you will not experience boxing. So, this already looks like something that would have been boxed, right? Because option of a term ID, the way we defined it before with an AnyVal, that would have definitely been boxed.
Yeah.
So we can actually probably take a look at the bytecode, right? Well, why not do that?
Yeah, we definitely should.
And the only allocation that is happening is it being boxed to integer. So there's no occurrences as a class existing anywhere. But again, for, I guess, the same reasons, right? The same reasons that we had with kind of the generic parameters and the AnyVals. You still get it boxed to integer because, as far as I know, you can't really have an option of a primitive type.
That's not
Scala.
possible in JVM. Basically, when you have generics, you should have objects. So
yeah. So, but as you can see, the entirety of it doesn't allocate occurrences as a class. So you save that one allocation.
So if we just go back to the definition of term ID and all these other opaque types. So basically what we have here is that unless you provide a smart constructor, you cannot construct term ID. So my question is there another way to kind of extend the opaque type if you don't have access to the actual source code? So when you cannot modify the enclosing scope of the opaque type definition.
So yeah, the whole idea is that you want to control the instantiation of those safe things as much as you can. There's a way to sort of extend it, and it kind of goes a bit further into the topics of Scala 3, but it does allow you to extend the type itself with certain things. But in terms of the creation and allocation, I think safe constructors are, the whole premise of it is that you want to remove them outside of the area where the users can unsafely construct those instances, or, which is more important, observe the underlying type. You want to hide the underlying type as much as possible so that the users have no way to do anything about it. But you can define extension methods. So that's also a new feature in Scala 3, but you could have done this just as easily with implicit classes.
Yeah, implicit classes.
Yeah, I mean, it's implicits for everything. It's implicits all the way down, obviously. But in Scala 3, the syntax is just a bit nicer. So you can say term ID, and you can define to integer. And then because it's a type alias, you get this. So let's create some data. Very simple.
Yeah.
Because those are integers, we just say 0, and we can say vector of 1 occurs, in 1 it occurs 25 times, in 2 it occurs 42 times. So we have this data.
So just one question here. So in the map, you actually use just raw types, raw integers, and your smart constructor does filtering on the value. So if you have this, it will be like some sort of inconsistency, right? Unless you use smart constructor inside the scope as well.
Obviously. Yeah. So the idea is that the scope where you define this is the only safe space, well, the only unsafe space where the underlying type is exposed. Everything outside of it will not be able to do what I just did, but often you want to do this. And I actually have a use case for this sort of thing because the type is opaque. therefore certain things like implicit resolution for it might not work. So if we had like a type class, right, trait show t as string value t, and it returns a string, right? So basically, if we have a type class instance of show for integers, we do not automatically get a type class instance for term ID outside of the scope where it's defined. But in here, we can actually do it. So we can define a function like this, show term ID, which will be, I'm going to be used a new syntax, but
yeah, I guess we need to talk about this sometime later.
Yeah. And we can define that it actually provides a show of term ID. And I think you can actually do this. Yeah, see, so this allows you to define within that unsafe space all of the sort of inference things that you want to be able to do because you have access to the underlying type, which means that if we have, I'll show. See, I'm mixing like new and old Scala 2 and Scala 3 implicit stuff.
Yeah.
Show int, so that would be show of int as string to string. So when we have this, we should be able to use the trusty old implicitly to get a show of term ID. Yep, and the reason we get it is because we define it here. I think if I just remove this.
Yep.
Yep. So, and that's the thing. So you can, in the unsafe scope, you have access to the underlying type, and because it's just a type alias, all of this stuff just works. So this, after removing term ID, just looks like an identity function.
Yeah.
It actually is kind of implicitly summoning the implicit, but because the type is opaque, you can do this sort of stuff. So yeah, this scope is unsafe. Anything can happen there. Outside of it, it's very tightly controlled, which is really what you want, in my opinion.
All right. I mean, actually, I love this feature. The fact that you don't need to, do this wrapping and unwrapping and all this stuff, and can use the type as a type alias. This should really cut on the boilerplate. This is very nice.
Definitely. And lack of allocations as well.
Yeah, for sure.
Which is a huge win.
All right. So I guess with opaque types, it's more or less clear. Let's say one of the other features that is not so clear to me, but let's say that I am a little bit more excited about, maybe not, fully justified, but let's talk about union types. Like not the either and the enums, but real union types, the way Scala 3 defines them. So could you maybe create a new file?
Yep, there we go. We're going to go into unions. I'm going to call this unions. We're going to remove that stuff. Don't need a tree. Well, we actually might need it later on. And I'm going to just change blue to keep running unions.
Okay.
Okay. So union types, I think I first heard of them in TypeScript, because TypeScript right now has all sorts of features with types. And I'm glad that the JavaScript community is using TypeScript.
Yeah, actually, it's really surprising to me, right? So it's just 5 years ago, JavaScript folks just didn't consider types as something of value. Now we have a TypeScript community with some very, very advanced type features, like singleton types.
Exactly.
This is not really mainstream, even like in Haskell. It's not baked in, sort of. So this is very surprising. So please go on.
And by the way, by the singleton types, you mean like something like this?
Yeah, exactly. So
Where,
when let's say your type is just strings yes or no. I guess in TypeScript, I'm not like an expert in TypeScript, but it can be, I guess, something like this. So, and there are only two possible, basically when you have anything else, the compiler will complain.
Yeah. I'm going to get on my high horse and just say that singleton types are in Scala since 2.13.1 or something.
Are they?
But now you can actually, yeah, like this is valid Scala. This is valid Scala 2.13.
Wow.
Yeah, for real.
Wow, I guess I missed quite a few things.
So actually, let's check if that works. There we go. So it's not an ID. Like the compilation error is not fantastic, but
oh my god,
it checks this. Yeah, it's been like this
forever. This is
magic.
Did not expect
and
that.
And more, I think, like you actually wrote the syntax for. Well, let's see if that works. Yeah, it does work. So union types in Scala, same syntax as you would expect. If we do this, complain. Yep, there we go. So it's not an actual type, and no should work as well.
I'm not sure why I'm so excited, but for some reason it just feels so magical.
Union types and singleton types, I think, go really, really well together to limit certain things, but it depends. Yeah, because those types only exist at compile time. They get fully erased, unlike anything that has to do with allocation. So you can sort of, I guess, go away with not using like an enum for this, because you can do the same thing with enum.
Oh yeah, for sure.
But it would be a bit more verbose, and also the presence of the enum will be apparent at runtime. Whilst with the union types, if it's done right, then by the time the compiler has finished all of the phases, they're completely erased. So if your program type checks, which I think is why it doesn't actually, unless you infer it correctly. So in this situation, for example, if we remove the annotation, you can see that the type of X is actually just a string, which sort of makes sense, right? It makes sense that it's a string because it's the simpler type. It's the, lowest upper bound of whatever this value is. So
yeah, I mean,
it's not even the singleton type.
Sorry, maybe if we could imagine something like this, like type, right? And then when you have, you probably don't want this to be inferred as small int, right?
Exactly, yeah. And especially if you're doing things like branches as well, because you can create int, right? And if you don't put anything here, if 42 equals 42, you want to go to 2, else you want to go to 35. You don't actually want it to be 2 or 35. So
yeah,
even though that's possible, actually, is it possible? Is it going to? Yeah, it actually infers like this. So it's crazy. Yeah, and it actually infers the union type. Well, I mean, correctly puts the
type checks, yes,
types in there. Yeah. Well, that wouldn't work, obviously. So you wouldn't want that. And the good thing about the union types is they're not present at runtime. So you can define your own things like what can you do? Error. And you can just say it's either a string or it's a integer code or it's there's no error. That's a horrible error modeling. But if you have a function,
I think it does the job.
Yeah.
I mean, we earlier, kind of talked about types in programming languages, right? Like strings and integers, that's all you need. So
yeah, I mean, yeah, well, I'm not going to get angry over this. I'm not going to get enraged. I'm just going to quietly agree with you. Yeah, so are you working with a C library? because if the error is integer, that's usually a C library. So you get, exhaustivity and you get a match error. But we should probably take a look at the runtime, right? And actually see if the union type is actually erased.
Yeah, let's do it.
Because that would be good. I'm going to remove all of the unnecessary stuff. Right. Bytecode, come to me. Right, so where is it? Unions is in here.
I actually can see the bytecode.
Oh, beautiful. Okay, so fail return object, which it's because all of them are probably boxed, because it's a box string, string, integer, and unit. So it has a boxed unit. It has unboxed to int. Interesting. I don't see. Well, we can take probably a look at the fail method itself to see what does it actually do, right? Where is it? Oh well, actually, I can't find it in here. I can't find the definition of error. So the class error, which we defined as a type alias, wasn't actually created. So I think that's good enough indication that it doesn't create an anonymous class for it.
Yeah,
is it a good enough indication?
Yeah, I think so. Works for me. I know something that I'm a little bit more interested about. Let's say when you have, when you work in a type safe environment, let's say a first concern is do it right and then do it fast. So I'm a little bit less interested about boxing behavior with regards to union types, but more about what sort of type safety features this type give us, and what about the ergonomics. So let's say since we have the error type here, one of the difficulties when you have your type safe Scala code is combining errors or working with errors of different non-intersecting types. Let's say you have two services, and these services, talking to them gives you different types of errors. So there are not that many things you can do about it. You either fold all your errors into a single hierarchy, which is workable, but not ideal, or you sort of wrap these different types of errors inside another object, and then you do some typecasting or type checking at runtime to see what is there, which is again not super ideal. And since here you have union types, and this is something that don't require you to define the class beforehand, it seems like an interesting instrument to see whether the type handling can be more ergonomics when you have to work with different kind of errors inside a particular piece of code. So what do you think about this?
So I think the answer is probably going to be not much, and the reason for that is specifically because of the specific type. But we can probably experiment with this. So let's as I said, I'm actually not a big user of TypeScript, or I haven't actually worked with union types at all. So I'm interested to see what sort of ergonomics this can give you.
But we can try this out, right? If the feature is there.
Yeah, exactly.
Let's see
and see what it looks like.
Yeah.
So let's just define two enums for errors, and we're going to look at probably two different ways to model this: the simple one, and the full union type one, and the full kind of either. So more like a bifunctor monad, if you wish. So the first one we're going to look at bifunctor monad. So we'll just say that we've got this either error 1 for our service 1, which returns a string, and let's say this one returns an error at this point. And we're going to take another service which has a different error hierarchy, and it returns, well, I should probably do this. Okay, so this compiles, that's good. And let's define a program. And I'm going to use something that people are going to hate me for. I'm going to use optional braces. I'm not going to use braces at all, which is a new feature in Scala 3. We're going to talk about it at some point. But it's just nicer. Oh, not that. Come on. So result 1 is going to be from the service 1. Result 2 is going to be from service 2.
And just to note, this is where previously everything would just fail, because you have 4 with different kind of types on on either.
Well, actually, I think it can unify them
to any.
I think it will. Well, actually, the lowest upper bound on. Well, in this case, yes, it would probably unify them to any. But if you were using throwables, then it would probably unify them to a throwable or something that inherits from exceptions.
Right.
And actually, I think in this case, we'll not get a failure, but we're also not going to get anything useful. And let's see what the program. Yeah, you can see that it's unified to object, and I think it's unified to object. I don't know where the object comes from. I think it's just like a Scala 3 thing, but it's technically any. So it's unified to this as well.
Right. So, but we sort of expected this because this is the default behavior. That's like the compiler does not infer union types.
Yeah, it doesn't want to make an assumption that you wanted a union type. So it looks for the simplest possible bound. But if you tell it that you're okay with it to unify, I think program becomes. Yep, that's a. So it gives you the error. So it infers correctly, and after that, I think you get proper existivity matching on this. So let's just check. So our success is string. So that's good. We can also get error 1. So that's also a good case. And we can also get error 2, which is also a good case. So this compiles, which to me looks okay because there's no other alternatives in the either.
Yeah.
But what if we remove this? Yep. So it says, and it actually gives you like all of the possible alternatives from the enum, which might be like what you want or what you not want. But so it gives you existivity matching on this.
That's good. That's good. But I guess there's another thing. So let's say you have like one program that returns you like a union of error 1, error 2, and then you have another program that just returns you an either of error 1 and string. So can you combine them?
Okay, that's cool. Let's just do that. So 1 is already annotated, and then this one will just get from a service 1 of a program. And it's going to do this, right? And now we're going to combine those two. So that's program 1, program 2, program 2, and we're going to yield So let's see what the type of combine is. Well,
actually, it was inferred.
Yeah, it unifies it correctly. So as long as you have, as long as you have it on the outer bounds of the programs, then the composition works the way you would expect.
So I mean, this sounds like at least this looks like an ergonomics improvement to me. What do you think?
Yeah.
Are you convinced that this is promising?
It's promising. I have my own opinions on the fine-grained error handling that kind of goes down the divide line between certain things. Because, like, for example, in the error 1 and error 2, this either could theoretically, because it's covariant, in the error channel, like what if I throw an exception in here, or just do like left of throw an exception? So that would be an issue because that error is non-representable. It will still be acceptable, I think, in the for comprehension. So those things like this, I think there's a difference between handling errors and handling invalid states from the service. So errors, the way we see them in the Scala code or like Java code, those are, things that can throw an exception, just break everything. But then there's also invalid states, and the invalid states, I think for invalid states, this looks actually quite good. I wasn't convinced before, but I think it doesn't look bad, and just doing an annotation here and there and being able to then compose the programs together, as long as you introduce the union, right?
Yeah.
Like if you introduce the union in one type signature, it will sort of propagate and it will start inferring unions for you, which is nice. But for the actual kind of full scale error handling, this error channel is hiding an important aspect of the fact that certain things that can happen are not represented in either of the hierarchies. So
yeah, I understand. Maybe like a silly question, but what if you flip the arguments to union type?
So it's commutative. It doesn't really matter.
Should be the same, right?
Yeah, and I think you can actually repeat them as many times as you want. So that should give you the same result. We need to probably remove our own. Oh, I think it's just a bit of outdated, and this thing. Yeah, so it's exactly the same result.
Yeah.
And if we copy this, I'm actually interested. That shouldn't have. Well, it's an interesting bug.
What do we see here?
So in the bloop, you can see that it actually sees. Oh no, wait. Did I mess this up somehow?
I think you removed both branches. Look. In the match.
No, that's all. Yeah, just one. It might be an actual bug. It might be seeing, so it might not be removing the repetition. But for all intents and purposes, the way this union value works is that you can only get only the unique elements of it.
Right.
And
so the order doesn't matter, and the repetitions should not matter as well.
And I hope associativity doesn't matter either, because like that would be really weird. So what would that look like? Well, this makes it work. So, yeah. As with many things, with Scala 3, a lot of the libraries are already published which use the subset of the Scala 3, which is compatible. And there's a lot of features that are compatible with the Scala 2. So a lot of things that are fundamental to, say, the work that we do, like Cat's effect and like things like Circe and JSON parsing and etc. All of that stuff has been published for Scala 3 for quite some time, even the current versions, without major breaking binary changes. So where my worry lies is the new features. I think the new features are cool, but the testing required to get them right has not been kind of done yet. With all the older features, there's a Dotty community build, which has been running all of the biggest libraries in the ecosystem against every single build of Dotty, and the contributors and the authors of the language have been contributing fixes back to the libraries and to the language when they found bugs. So we know that it works for all of the older stuff, but all of the new features, I wouldn't be able to say how reliable they are. But then again, it's a milestone 3, so like what do you expect?
Yeah, for sure. All right, so maybe before we wrap this up, we could talk about a couple more things here. So I guess this is a small feature, but a highly requested one. Could you tell us a little bit about strict equality in Scala 3?
Yeah, so strict equality, when I was experimenting with it recently, I think I found a bug in it, but the idea is to introduce something in the language itself that will allow people that desire to write programs in a way where kind of multiversal, universal equality doesn't work. So let's see if we can reproduce this. So equality dot Scala. So at the moment, things like hello equals 25. Only a string cannot be compared. I think we're talking equals. Yeah, so you can sort of do this stuff, which is not fascinating. And to be honest, the compiler doesn't produce anything. And the reason for this is that equals is just, objects all the way down. I clicked through, but it doesn't matter. So
Yeah.
It's objects all the way down. And obviously this poses a problem, even though in some of the kind of Java code bases, this is fundamental to how some parts of the code are written. But in a lot of the Scala code bases, we tend to utilize type classes. And one of the type classes that has been highly requested is sort of compiler support for being able to control the equality and comparisons in a very fine-grained way. So to do this, we'll probably need to change a few things. Let me just remember what the flag is. So, okay. In the build SBT, let's just add a Scala option. I think it's language strict equality. Metals asks us to import the build. So that's good. And whilst that's happening, I hope it doesn't break anything in the other places. Right. I'm just looking up some stuff. 1 second. Right, equality. So certain things that we should be not able to do is do those comparisons. And we kind of want the compiler to help us with certain things. It can't help everywhere, obviously, but like in here, for example. But when it comes to objects, we want to control that in a much more fine-grained way. So for this, let's define things like case class tree. Actually, I need equality, right?
Yeah,
there we go. So equality. Okay. I hope it picked up the flag. Let me check on SBT.
Sure.
So I'll just do case class tree integer, case class blah integer. Oh, I already have a tree. Foo and bar. So let's see if we can get this in a situation where equality helps us.
Okay.
So let's put like this. Foo and bar is going to be long, and what we're going to do is not make them case classes and just do new foo equals 5 of 5 and new bar of 25 long. So what we should get, so we get values of this cannot be compared.
So what if you remove the option from build SBT?
Yep, let's see. So we reload, we compile, and it actually compiles now. So we just need to import the changes. Because like SBT and Bloop, they both have a snapshot of configuration.
Yeah.
So now it compiles. And
could you reload the terminal?
Which one? The bloopy bloop?
Yes.
Yep. So that works.
Okay.
Now. And Yeah, and the way the strict equality is supposed to work is
Maybe just before we go to strict equality, what exactly is wrong here? So let's say in Java. In Java, there is two type of equality test. One that uses the double equal sign, and this is just referential equality for objects, or real equality for primitives. And there is equals, which is your usual equality in a usual sense. So in Scala it is different, right? So the double equal sign is used to mean semantic equality rather than referential equality. Is that correct? So it's a sort of an overloaded operator.
Yeah, and it actually it delegates to equals, I think, under the hood. So so the double equals delegates to the double equal sign delegates to the definition of equals method, and usually the case classes override that equals method and produce. So for example, case classes generate their own equals method that means semantic equality. But because of the definition of this equals sign, everything can be technically compared with everything, which when you're writing code, that's not really what you want to achieve. You want to find places of your code where you're comparing types that should never be the same. So the whole idea is that how do you encode this information that the comparison between the two is useless, like it can never succeed, and therefore it's either a bug in your code or something you could just remove and replace it with false, which could also help with optimizations, I would guess. So
and maybe just to clarify here, so this again has roots in Java, where the contract of equals method is that it should be able to handle any type of object, including null, and the same thing applies to Scala's double equal sign. And as you said, usually it's not what you want, but it can happen, especially during refactoring of the code. You can just swap one object for the other object and your equality doesn't make sense anymore, but there is nothing in the compiler that is warning you about this. Maybe, is there actually warning that...
I think, yeah, Scala 2 can warn you about it, but not in all cases. And in my career, there's been some mess ups, like I had a function that was returning a string. I then changed it to a function that returns an integer. And then I still had an assertion, which was testing that invocation of test is not equal password or whatever. So
all right.
I was like, yeah, like that sort of kind of works.
I can see how this can
go
wrong for sure.
Yeah. So, and the compiler is not helping me here, but also because it's delegating to the kind of Java semantics where everything can be compared with everything, it just says, well, yeah, sure, they're not equal. I mean, I did my job.
Obviously, right?
But that's not good enough. Yeah, like, I don't know what you're asking of me. I did my job. They're not equal. So maybe the compiler is supposed to help you a little bit more. And I think a lot of the developments are in not letting the compiler kind of say, oh, I'm sorry, this is how it works at runtime. So
for sure,
this is the improvement towards that, just to make sure that you get an actual error.
For sure, yeah. So, if we go to strict equality and we add this extra flag.
Yeah. So after that, everything, as far as I understand the feature, because the name of it's changed ever so slightly, it became kind of opt-in. Everything, all of the equalities will be implemented in terms of these CanEqual type class. So, which I wonder if I can take a look at it. No, I probably can't. So this CanEqual type class, or EQ, is supposed to be defining the relationships between types, and you should be able to use that feature. So at the moment, it says cannot be compared, which is exactly what you want. But we can, I guess, sort of define this equality notion, maybe foo and bar. Actually, I don't know what sort of methods it has. Oh, okay. New CanEqual foo and bar. And no, it's actually, how can I create my own? I mean, you can see how prepared I am for this, right?
For sure.
I've been working hard on getting those examples right. Right. So in Scala 3, the idea, and this idea is hidden behind a compiler flag, and the reason it's hidden behind it is because it's a fairly strict definition of how the values are compared with each other. As we said before, the double equal sign delegates to Java's equals, and therefore it uses the same semantics, so you can compare anything with anything. But if you want to put a bit of control over that, you should be able to use this CanEqual type class. You can see that even comparing values of the same type doesn't work anymore. And the reason it doesn't work anymore is because what if, for example, come again?
Wow, I mean, I'm just surprised.
Yeah, so the double equal sign in the under this flag is completely different, and it completely is rewritten in terms of this CanEqual type class. And the reason you might not want to have equality and prevent this equality comparison anywhere in the program is because what if this class holds some sort of internal state, right, that can be modified from outside? It's not observable. How do you define equality? So in this case, how do we actually make it, like, how do we allow it to compare? Well, we can allow it to compare by using this derives, I think, CanEqual. Maybe this will work. There we go. So now you can actually compare the two types. So, which means you can define the types yourself and the kind of combinations of types that are allowed to be compared. But obviously this is not a structural comparison because it still delegates to equals. So yeah. I think if I did, well, actually, yeah. So how about that? I'm going to do it, make it a case class, which doesn't have, not allowed to compare foo and foo. I will say that, okay, don't worry, it's okay to compare those. They are meaningful. Yeah, and now they're equal because they delegate both to the structural comparison that is generated for you for a case class.
Let's actually unwrap this. I mean, there was a lot of stuff happening right now.
Yep.
So first thing that you did here is kind of you added the derives clause, which is, I guess, some Scala 3 magic that generates this type class definition.
Yeah. So if we just remove this and make it a bit simpler, this derives keyword, all it does, so when you say derives show, the type class that we defined before, what it's going to complain about, well, actually, I think show is existing in the prelude, or maybe this is happening before the, there we go, okay. What it actually does, it looks for the companion object of this type class and calls a special method called derived, and that's it. That's all it really does. And that derived method receives certain parameters that help it to derive a type class instance.
Nice. All right.
And that's what really useful. But for CanEqual, things are a lot simpler because we don't actually need to use this. We can access it directly. So as you can see, before we couldn't compare the types of foo, right?
Yes. And just to, again, note here, before we had just class foo, and by default, this class doesn't have an overloaded definition of equals. With case class, you actually have a definition of equals generated for you by the compiler, but you still cannot compare them. So we see that this double equal sign is not using equals from case class. And only when you add derives CanEqual, this whole thing actually works.
Exactly. So, and the reason is that in the Scala code bases, it's a very rare thing to see equals because the double equals as a method call, the double equal sign just does some null checks and basically calls the equals method anyways. And the usage of case classes is prevalent as well, and all of those hash codes and the equals, everything is generated for you, so it's very nice. And yet still, because of the way the double equals is implemented, it has no constraints. So majority of the code bases will be using this symbolic double equal sign or like exclamation mark equal sign. And so this is the target of this. And the only way to make it nicer is if double equal sign was actually not taken an any like it does right now, but it was actually taking some sort of evidence that the classes can be compared.
Right.
And that evidence is exactly what you need to provide. So you don't actually need to derive anything or put any annotations. You can provide the evidence yourself because it's just an implicit. So, or in Scala 3, they're called a given. So you can just say CanEqual foo. So that means that you can compare foo and foo together. Yeah. And you can call this universal derived method yourself. And voila. So because in this scope we put the evidence that we ourselves allow to compare foo and foo, the compiler says, okay, that's good then. I think that's kind of really powerful and allows you to put a much tighter control over your code base.
Yeah, one thing that is probably surprising to me is that, when it comes to case classes, usually you use case classes so that the compiler generates this semantic equality for you, because usually those case classes are just, kind of boxes for data, right? And the usage was to have like semantic equality anyway. So when in Scala 3 you do not generate CanEqual for case class by default, this means that a lot of code that was already written with the assumption that case class gives you the proper semantic equality will require modification.
I'm not sure I follow. So the method is still generated, and this double equals will still delegate to the generated method of the case class. The only difference is that all of the, like when you flip that flag, you will immediately notice that you're not only checking referential equality, and the structural equality, you have control over which ones are allowed to be compared. So theoretically, if you flip the flag and you find yourself in a position where this code is found by the compiler through 25 different layers of indirection, then that obviously will need to change. The smaller change is obviously when the compiler complains about this code, which is pretty much exactly like all of the code used with case classes is designed for, as you said, kind of a structural comparison. When the compiler finds this particular bit of code and complains about it, then yes, you will need to change some code, but this changes it in every single position anyway. So as long as you don't do things like this, which technically don't make sense, because unless you define your own structural comparison for regular classes, deriving CanEqual for them basically gives you back the old behavior where you can compare them to anything. Well, not to anything, but to each other without having any structural comparison. So compare by reference. So I guess it introduces some changes, but also they're fully opt-in and they do not require every single use site. So if we didn't derive, actually, let's see if that works. So if we didn't derive the CanEqual, the compiler complains, but the structural method is still there. So that still compiles, and it's not equal. So it's still there. It's still generated for you. Still work exactly the same way. The only thing that is added is that there is a restriction on specifically the double equals, not the equals itself. Just the double equal sign.
So let me maybe elaborate here just a little bit. So in Scala 2, what we had for case classes, we had like compiler generated equals, and we had this thing to be the same as equals, right? And basically when you had two case classes, like two instances of the same case class, you could do this easily. A equals to B.
Yep.
Right? So, and the usage was that if you have a case class, you can compare them structurally or semantically, and it'll just work fine, right? And then in Scala 3, there is this new flag, and this flag changes the behavior of double equal sign, right? But we still have these case classes. We still have the proper equality for them. So my question is, why Scala 3 by default doesn't derive CanEqual for case classes as it did in Scala 2 for the just regular equals? This would mean that code in Scala 2 would be compatible with this flag in Scala 3 without any changes from the user. So, I mean, they definitely chose like a more cautious sort of approach to rolling out this feature with strict equality. But I'm just wondering whether it's really worth it. Not super clear, because you make a lot of code just incompatible and requiring this, mechanical change in many different places in your code base, which doesn't seem, not really clear on the pros and cons.
I think this is such a big deal. Like, all of the other new features are quality of life improvements. They have effects on the type system. But in terms of safety and refactorability of the code, I think this one has more consequences than the rest. And maybe this opt-in behavior is designed because not everything in the standard library yet takes advantage of this CanEqual. Like, imagine if you had to parameterize like a list.contains on the CanEqual, right? Like, that's where the big changes would actually happen. For the most part, you have a lot less case class definitions than you have usages of those case classes. I think, like, in most code bases, that should be the case. So by doing this small change first and getting your program in a state where the manual derivation of CanEqual gives you the ability to reason about the program, and then doing the change in like 3.1 or whatever, where you actually need to parameterize the library, the standard library itself, on the CanEqual, because you can't really do list.contains if the values inside of that list are not comparable with each other. Like, you want a compiler error. So it's a much bigger change, because the amount of usage sites is disproportionately bigger than the amount of definitions of case classes. So I believe that you could do a Scala fix migration, and Scala 3 guys have been designing a lot of the Scala fix migrations to help rewrite the code. It doesn't rewrite under the strict equality as far as I know, but it's easy to add one.
Yeah.
But it's a much bigger change in the long run. But you can get a lot of stuff done if you just get the == sign working properly in your code base by just annotating the definitions of the case classes rather than all of the usage sites. Because, like, imagine if you had to propagate the CanEqual type class everywhere in your code base. That would make it much safer. You would not get into a situation of mixing stuff together, but it would become tedious. So I think this gets you a lot, and it's enough to verify how the feature works and etc.
Yeah, I understand. It just probably my point is that it just feels a little bit too conservative. But yeah, anyhow, maybe one additional thing here is that, let's say in Haskell, you can have like the language pragmas at the level of the file, or like a module, and this will turn on the behavior for this particular file. Is there like a way to do this in like with SBT? Let's say you turn on the strict equality only for particular files or particular directories?
Right. So usually in Scala, actually I haven't used this before, but I haven't used this particular version. So for example, in the Scala 3, you need, like, the implicit conversions are not going away. They're becoming a thing of the past with like new syntax and fewer guarantees on what you can and cannot do. And to turn that feature on, you just do import scala.language feature, implicit conversions, and that allows you to use it in the file without any warning.
Yeah.
Is there a strict equality thing in there? Oh, there is. That's weird.
Is there?
Yeah. Oh, okay. So that works.
So if you remove the compiler flag.
Let's remove that. Save it again. Import the build. I'm gonna reload the SBT as well, just to make sure that we get something.
Yeah.
So this is with strict equality on inside of the file itself. But if I comment this out, that works. Okay, yeah. So you can actually do that. You can enable it on a per file basis. And
well,
actually, yeah, go ahead.
But now there is even less reason to go with the conservative approach, right? I mean, you could make strict equality be derived for case classes by default, given that you can enable it like for a particular file, or even particular, I guess, like scope or like object or anything within the file. So, that's surprising.
I don't understand why it doesn't auto-derive for case classes. There's probably some pretty weird reason why it doesn't do that. I wouldn't be surprised if that reason will sound crazy, but also will be due to some interop guarantees. Like I think your arguments make sense. Like if you have case classes and case classes are already used for structural comparison only, it doesn't make sense to restrict the comparison between the case classes themselves of the same type. So at least like this one, the foo comparing to foo is the most conservative. But maybe there is some issues with like generic case classes. That could be a problem. How do you always derive there?
Right. Yeah. I mean, that's a good point. Yeah. I guess that would be fun to learn more about. But I guess we have spent enough time on this. So let's perhaps finish up with something easier and of course less controversial, like the new syntax.
Yeah.
Optional braces. Tell me what you think.
It's interesting. So let me just do a new file. Optional braces.scala. So what the most controversial feature by far is optional braces. So in Scala 3, by default, the braces are optional in most of the definitions. And we actually use this feature.
You mean it is on by default in Scala 3?
Yep, it's on by default. So if you take a look at the build SVT, we actually, if I remove this line, right, we don't have any single flag that we configure. And if I go to SVT itself, I'm going to do show Scala C options, and that's it. So like all it does, it has a boot class path and nothing else. So we're not configuring anything. So, and we get that by default. And I'll be honest, I like it, but also I'm sure stuff will break. So let's see what that looks like. And the stuff will break in weird and wonderful ways, probably. So you can define your own trait. Wow, I'm really bad with names. Trait. I mean, come on. So the old definition would be hello. So it takes a string. I'm going to do like a medium-sized example, and you can do s match and then case hello, and then you'll do if s. Well, I already know it, but whatever. If true, then print s. Right. So we've got this, and then let's call this new trait controversial. So first of all, I have a muscle memory on braces, but I'm trying to remove that. So colon, yay. Tabulation, there we go. So we can do that. So we're not putting any braces. We can still leave like dangling equal signs and whatnot. We can use indentation where we would use braces. So we can say case hello, and it sort of kind of works. And also it removes optional braces around the arguments as well. So you can do, I think this will work, but probably not. I can't imagine how it, yeah, there we go. So, but this, nope. So that I don't remember how it works, but I know that this should work.
It says that like the braces expect then. All right.
Yeah, there we go. Oh, yeah, I see. I see where you're reading this. I was like, oh, how do you know that? So, yeah, you could do this, which...
Man, this looks a lot like a camel now.
Exactly, yeah. And it's interesting because so if you know about Lee Howie work on Ammonite requests and Cask and like all of those libraries, I love them. I use them every day for scripting, but they have a very Python-like feel to them because I used Python both in production and in scripting, and mostly for scripting actually in the last few years, but until I switched to Ammonite full time. So there's always been that goal of going after the Python community because there's a lot of developers in there, and Python has this kind of natural feeling syntax. And as of recently, Python is adding static types, which are just annotations, but whatever.
Yeah, good luck.
Yeah, so they're adding those in, and there's always been that, not goal, it has never been publicized, but the idea was that, yeah, like given that Scala has pretty decent type inference for the language running on the JVM, and like with the features that it has, like implicits and stuff, and it has syntax extension, and now it has this optional braces syntax, which uses indentation, that it is possible that a fair chunk of Python developers would consider something like Scala as the language of choice, because Python has always been the first simple language, even though, opinions vary on that.
For sure.
Yeah, like certain things in Python. I mean, every language is complex in its own right, so I can't really. I mean, we're looking at a language that has implicits and inheritance all bundled into one, so I can't really say that Scala is very simple. But yeah, like that was the idea. And so I don't think the optional braces are designed to get a chunk of the market in this way. I think it just makes sense because if you can implement that in a parser, certain things are just not required and they might clutter things. But also another thing is that certain tooling like Scala FMT that enforces the formatting on a file on an entire project, first of all, they don't fully work with Scala 3 yet. There's still a to-do list. As with many other tools, like you can see that IDE and SBT and Bloop and all of that all works, that's beautiful. But certain tools like Scala FMT for formatting don't work. And the reason that it's interesting is because you can format this stuff whichever way you want it. But now you can see that Scala 3 will tell you that it's indented too far to the left, because it now checks the indentation. But in Scala 2, you can do all of this. Like it's a free for all. There's no rules. You can just put stuff. Well, I mean, you can't do that, but you can do this. So, and this is complicated because I've been in the situations where, due to misconfigured CI, we had Scala code not formatted or not checked by the CI for a long time. And then someone comes along and says, oh, crap. Okay, so this all looks all over the place and it's difficult to read. And then you run a formatter and like 75 files are changed and there's 4,000 lines of change. So that's problematic, and kind of indentation helps you avoid that, because if we just remove this nightmare, you get actual compilation errors. So if you misindent. So I guess, yeah, that looks like OCaml, or does Haskell have this? Yeah, like
Yeah.
Haskell has this sort of syntax, right?
Yeah. Probably one thing that is, sort of an obvious problem here is when you have this extra braces, you can copy paste any snippet of code anywhere, and if it's well formed, it will just work fine. And now with indentation, it seems that refactoring can be a little bit less effortless. Well, we'll take more effort.
Yeah. So technically that's true, and absolutely will be a pain. And the reason it's going to be a pain is because the tooling is not ready. I feel like the main arguments from the side that supports the optional braces is clarity, less code, less variation in the code bases. And the argument on the side that supports the optional braces is that the tooling can be made to work with it. The argument of the opposite side is that Python, as an example, it doesn't work perfectly, and the refactoring bit is something that I can actually personally sort of attest to, that it is a problem of pasting something, and specifically if you're pasting it from like Stack Overflow, from a markdown document, from a text document, or if you're pasting it from Slack, and Slack just adds some sort of formatting to it, so you have like double lines and etc. So everything in technology is just terrible when it comes to copy pasting code, which is surprising because that's like 90% of the stuff that we do, right? Copy pasting code is what we're designed for, and yet our tools for that are terrible. So it can be solved. I've written all of the examples for this, and I've written some more complicated code in this style alone, and it wasn't that much of a problem. But obviously this has nothing to do with working on a large project where many people are working on, and where you need to move stuff around quite a lot. So, but at the very least, because Scala is a statically compiled language, the statically typed language, the amount of stuff that you can get by improper indenting something is very, very low. So compared to, say, stuff in Python, like you can get indentation produce different results.
Yeah.
But in Scala, it's not zero, but it's low. On the other hand, it's still optional. There's been no word on when it becomes kind of, enforced.
Right.
And it definitely won't be for, I believe, foreseeable future. So you always have that flag, and you can kind of dabble with it and experiment, but you can always opt out and just have regular old Scala. But I think one of the changes that went in to support this, which is somewhat annoying, is things like, so if we have a list of 1, 2, well, actually, what am I doing? I've got ranges, 1, 2, 25 for each. So if you wanted to annotate the type in Scala 2, you would just say I integer, and then you would do this. Actually, I wonder if that works. Yeah, so it says parentheses are required around the parameter of a lambda. This construct can be rewritten. Actually, that's what the Scala compiler also does for you. So it gives you a rewrite flag that will rewrite your code automatically if you wanted to. But this is one of the changes. So you could do certain things like this, and then it would work. But I think to support indentation style, you now have to put parentheses. But you can see you can sort of mix and match the two together, right? So you can do print line I, and inside of the brackets, actually, the indentation doesn't matter, as you can see. So you can sort of mix and match together and do certain things where it makes sense to use indentation-based syntax, but probably your colleagues will hate you for that. So the companies will need to make a decision and stick to it, but I don't think it's nearly as controversial as the arguments on the internet will make you believe.
Oh, for sure.
But
Yeah.
that's true for all of the arguments on the internet. So I don't think it's that big of a deal. I think it's a very nice improvement, but you can always turn it off and just not worry about it.
Yeah, and just to comment on what you said earlier, that like unlike Python, Scala is statically typed. So if your indentation is incorrect, you will likely get a compilation error.
Yeah.
And this is much better than a runtime error. So which is true. It's there's just this bit of experience that I had with Haskell, and Haskell has some rules about indentation, how to indent stuff, and all this. And just recently, I was doing some Haskell after like a year-long hiatus, and obviously I forgot all the indentation rules and stuff like that. And yeah, I mean, I obviously messed up indentation quite a bit, or actually not like in a huge way, but slightly. And I got some very weird compilation errors. So, and it wasn't really clear that this is because of indentation. And let's say when you have a very generic code, when you have like monad stack, like transformers here and there, and all this kind of stuff, it may not be at all obvious that the issue is due to messed up indentation rather than something in your code. And I think it took me like a while to realize that the indentation here is not right. So, I mean, it is good to have a compilation error, but sometimes it can be very misleading to have one.
Oh yeah. Like one of the features that we haven't talked about is the fact that you now can declare top-level members in all of the Scala files. Like you don't need to wrap them in objects, so you can do things like this, right? And you can define methods as top-level. Blah blah blah.
Yeah.
Not even main, like so, and that's the problem because. So let me just do something. So you can define this, and obviously, if you're indenting stuff in a super long trait, then you accidentally just basically test is now a top-level method, and if it doesn't use any state from the trait, you would get weird compilation errors. So I think that's one of the reasons why you can actually do this. So Scala 3 adds this end keyword, so you can actually delineate the blocks to avoid this indentation. And I think it works in many cases, to be honest. Maybe end blah. Yeah, that works as well. So
oh my god,
you can actually.
Sorry,
that gives me like Pascal vibes or something.
And I have this like flashbacks from C when you have this if defs, like long if defs, and you have the end of particular if def block. Wow. But
that's again optional, and that's really for you to prevent yourself from doing any ambiguity. So specifically for this use case where you're putting something somewhere, but you need to know the end of it, because all you have is like tabs all the way down. So I think this looks weird, and in Scala that's the least you would expect, because Scala is all about the crazy brackets and the braces and the parentheses and like the 55 type parameters. But this looks imperative as hell, and I think nice, but we'll see how far it sticks. Like I've seen that a lot of the libraries that are cross-compiling for 2.12 and 2.13, big code bases, because you have two options. So you can either invoke the Scala 2.13 library from Scala 3 because they're binary compatible, or you can use basically completely new code and rewrite your entire thing. I've seen that a lot of the people are embracing the significant indentation syntax, even though they have a large code base already written with braces and brackets and parentheses. But I've seen that a lot of the people just prefer to not write the Scala 3 in the same style, but rather embrace the change. And that's pretty interesting. And does that equate to the professional experience of using Scala work? Probably not, because you don't have as many contributors. Like, the open source is a very lonely job, so you have one person and that person can decide a lot. So
Yeah,
yeah, maybe that's what makes it easier.
I see. Wow. All right. So that was very interesting, and it's I can say definitely that I learned a lot from this, and Scala 3 looks rather exciting to me. But there is one thing that we haven't touched on, which is not one thing, but actually many things, and this is all about kind of redoing the implicits in Scala 3, kind of kind of compartmentalizing the use cases and making certain patterns expressible in a nice way in the language. So I guess this will be like a very good subject for the next conversation about Scala 3. And but for now, this was super fun. Thank you, Anton, for your time. And
Thanks for having me.
all right, so I guess maybe next year we'll talk about implicits in Scala 3.
Yeah, see you next year.
See ya. Thank you. Cheers.
Bye.